Welcome back, my fellow radiation nerds! Today we will explore the radioactivity and the geology of the most common thorium mineral, monazite. Monazite is a brownish phosphate mineral, primarily known for containing several of the rare earth elements, including lanthanum, cerium, and thorium. It scores between 5 and 5.5 on the Mohs scale of mineral hardness and has a density of 4.6 to 5.7 grams per cubic centimeter. Compared to other thorium minerals such as thorionite or thorite, monazite contains much less thorium at around 6 to 7%. However, its widespread availability makes it the most common thorium ore, accounting for approximately 12 to 15% of the world's total thorium reserves. Monazite is most often located in placer deposits of sand and gravel. It's primarily found in countries like India, Brazil, South Africa, and Australia, but can also be found in many other places around the globe. Monazite is not a single mineral, but rather a group of minerals with very similar structure and properties, but with slightly different dominant elements. There are several variations of monazite, with 5 main types. 3 of these variations contain radioactive thorium, while another 3 contain lanthanum, which does have a naturally radioactive isotope of lanthanum-138, but its radioactivity is extremely low and generally difficult to detect, especially in the presence of thorium. Since monazite is rich in rare earth elements, it has been their primary source for many years. In the 1880s, Karl Auer von Welsbach was looking for a supplier of thorium to produce his newly invented thoriated gas mantles. One day he noticed that Brazilian ships use monazite sand as ballast, and soon Brazil became a key supplier of thorium for the production of his gas mantles. For many years, Brazilian and Indian monazite dominated the industry. However, after World War II, much of the mining activity was shifted to South Africa. Unfortunately, due to radioactive waste produced during monazite processing, it was eventually phased out in favor of bastonite in the 1960s, which contains much less thorium, making it safer to work with. In the recent years, the growing interest in thorium reactors as a potential alternative to the uranium reactors has sparked renewed interest in thorium. This shift could lead to increased demand for thorium and possibly bring monazite back into commercial use. I acquired my sample during a recent mineral show. It's the most common variation of monazite containing cerium, and it comes from Madagascar. Despite its small size, its radioactivity is easily detectable, reading at around 2000 counts per minute on my Little Model 3 with a 44-9 probe at 1 cm distance. Although I already knew from its chemical formula that thorium is present, I decided to do a quick gamma spectroscopy with my recent gamma spectrometer just to be sure. As expected, it revealed peaks characteristic of thorium-232 and its decay chain. I'd love to hear about your experiences with monazite and other thorium-containing minerals. Do you have any in your collection? And what other minerals should I cover in the future videos? Let me know in the comments below. Thank you so much for watching this video. I hope you enjoyed it and learned something new. If yes, please consider giving it a like and subscribing to my channel so you don't miss any of the upcoming content. Also feel free to check out my coffee page where you can donate a nice cup of radioactive coffee and support my work financially. And remember, stay active.